All right, we're up and running. We haven't done mechanics in a minute. So let's do some mechanics. Wait, 8. I'm just making sure these are the foundation forms. All right, first 8. Okay, good. Check limiting cases. Um, oh, okay. I know what cases they want us to check. These. Let's bring them in. Okay. So if r equals 0, it's basically a stick around the center. So that checks out, that checks out. That does not, that does not. If L equals 0, it's a disk. Hey, Walter. Around a diameter, I guess. So we won't be. Right now I'm just doing some mechanics studying, so this is physics. Chapters on torque. Same mass, same vertical span. Ooh. Oh, nice, Walter. What section of mechanics are you doing? Or what, like a topic within that? I have a feeling that 1 and 3 are equivalent. Relative motion, nice. Newton's laws of motion. Okay, okay. Hey, Slim. Uh, so what's happening right now is I have a poll running in Discord for another 23 hours. For when to meet. But I'm thinking that I mean right now it's pretty much split. So I might just choose like Tuesdays at 3 Pacific, unless someone else votes. But I guess sometime tomorrow or the next few days I'll hey, how do I sing your name? Boral? Bro, Arl. Hello. Um, I'll try and say an actual first meeting date that'll be in like 3 to 4 weeks. Yeah, I mean, I don't expect there to be a huge amount of interest anyway, but between you and Pinbox, that'll be enough for me at least. That's better math than rigid body dynamics. Whole month. I mean, yeah, that's a lot of stuff to learn. I haven't actually looked at the actual chapter of the book or what the problems look like. Actually, let me. I should figure out if I need to find a solution key or not. Where is it? Uh, oh, there's no bookmarks. I need to make my own bookmarks. It's annoying. Um, these aren't hyperlinked either. Um, oh, there's problems for each section. Interesting. Are there solutions? Okay, yeah, there are. It looks like odd numbers only and skipping a lot, but okay. Maybe that'll be good enough then, or maybe I'll still try to find a solution key. Um, have I worked on Griffith's electromagnetism? Uh, the only E&M book I've read is Purcell and Warren's. And hey, Sage, good luck on your exam. Um, so yeah, this is the only E&M book that I've read. I still need to read 10 and 11. Um, it's more intuition than mathematical, though. From what I've heard, Griffiths is a lot more mathematical. So that's probably your best bet for an E&M book. If you're already good with E&M, I've heard like I think like it's called like Jackson is the really hard one. But if you're not already good with it, I think Griffiths, from what I've heard, is your best bet. So I think 1 and 3 are the biggest ones, and I think they're equivalent as far as the moment of inertia goes. The issue with number 2 is that these points in the corners are the same distance away because we care about r squared here, so the distance matters a lot, and the mass is all the same here. These corners are the same distance as the corresponding like points on the circle, but the diagonal parts are closer in, so r is smaller. The same more does. Oh, uh, I haven't heard of that. If that's true, David J. Morin. Books. Oh, I guess so. Book of Rhymes? Oh, this just isn't even about math. He just likes writing, I guess, also. Hmm, interesting. The rhymes are short, so you could even read one. Oh, wait, is this the... Wait, 45. There's 94 in all. That's kind of interesting that they just have some of them, like, posted here. Hey, Aziz. You spend your life within the seats, staring at the stage. You let your fears run through the years and never turn the page. But if you dream of taking bows before a crowd that roars, get up, engage, and join the stage, and make the show be yours. I mean, okay. That's kind of saying, like, go for it. It's not saying, like, how, but fair enough. I don't know how you do that, Empire. I'm sorry. Um, um, stick around end. ML squared over 3. Oh, they're not. Hmm. We don't care about the actual thing. So I think A is definitely right. So the only question is really whether C is right. C just seems clearly wrong, though. Or does it? I feel like there's a trick. Or I feel like I'm gonna get tricked here. So let's think about this. It might be something like this. Like parallel axis theorem is how we get an ICM involved. And so D, I guess it's the length of the stick, which we're not really given, but we can call it L. Oh, that's sneaky. This is sneaky. We've got a sneaky beaver. Um okay, I think I see it. So the A that I'm saying is right. Let's start from there. I'm gonna plug this in for I end. Omega squared. So get 1/2 ICM omega squared, first term. The second term, 1/2 M L over 2 squared omega squared. And the thing to realize here is that this is basically radius and that's angular velocity, which is just regular velocity, tangential, of the center of mass. What a sneaky beaver. My spidey senses were tingling for getting tricked by Morn. Well, I haven't checked the answer to be fair, but I feel right. This is Torque Empire, part of mechanics. Okay, they made a point about saying energy is conserved. Like I could see that one going either way, but well, let's read the others. Also, why is this torque, by the way? Oh, because of the ball rolling. uh, no, I think it's just B. The ball rolling doesn't do anything. I don't think. Very weird one. How many multiple choice? There's 15 in total. Maybe we'll get to like halfway through, check the answers so far. Hey, Lucas. Yeah, what's up? So are these sticks just floating in space? Hey, Jasu. Oh, Jasu, I meant to ask you. Remember last time you were here, you're talking about how you're going to defend your PhD soon. Like, do you know when the actual day is? Nope, you want a date yet? Oh, okay. Jasu is about to get one. It's no pressure to Jasu, but if you want to like come on the stream and like talk about your thesis or anything, I think it'd be like a cool thing for people to hear about. Do you mean defend? Um, when you get a PhD, you have to make like an original contribution to that field. Like you have to do some like new research, and you have to present that research to a committee of professors who already have PhDs, and they like question you and make sure it really is new and worthy of a PhD, and that's called the defense. Hey, Volatiro, you have your IGCSE boards tomorrow. Good luck. That is weird because they I don't know how like I assume the stick is floating through space, but also CM velocity. I assume we have to worry about rotational and tangential. Yeah, and Jasu just loves being a student so much. I guess you're going back for just a bachelor's right after. Okay, so I guess oh, I didn't realize that. I know you two were talking about it. Um, or we're talking about like going for a bachelor's in the same country, but I didn't realize it was the same uni in the same program. Oh, yeah, I think we can do that. Okay, so Lucas, first, do you know what inflection point is? Like how to find one using derivatives? Okay, perfect. Yeah. So let's start with that. First, let's find f prime x. 4x cubed 3px squared plus 2qx squared, because p and q are just numbers. So we can still take the derivative as normal. There's no worries there. Now let's do f double prime. Ooh, people were sleeping. Well, well done, Jed. Come on, people. Derivative again. Okay. So now we set this equal to 0. We're sleepy? I guess so. All right, so I'm gonna, before I move on to the next step, I'm gonna divide 2 from each side of this equation, just to get rid of it. And they're asking, when does this quadratic have 2 solutions, 1 solution, or no real solutions? So I go to the quadratic formula here. Minus 3p plus or minus. All over 12. Then let's clean this up. Oh my god, Q. Okay, and so now you've probably done this before, but we can look just at this piece of the thing here. It's called the discriminant. Um, you need to get a signed ethics form saying I don't need ethics permission? What? Humberto, I prefer handwriting on paper, but for the stream I use a tablet. Okay, so now we can, like, this thing here controls how many solutions there are. Minus 24q. If there's 2 solutions, then it's greater than 0. That's the case that we're interested in. And so from here, we can name any p, any q we want that gives us greater than 0. So, and there's infinitely many choices. Everyone needs one, huh? Like ethics isn't like experiment ethics. Like that's kind of funny that a pure mathematician would need that, considering they don't really do experiments. Like for medical experiments, of course, one of those. Okay, yeah, that's super weird. Um, so we could choose like even p equals 1 and q equals 0 is the simplest choice, I think, because that just gives 9 minus 0 is greater than 0. Let me actually bring this over here. All right, so honestly, I guess I never asked you. I didn't realize that you already had a PhD. I assumed that you were a student. If there's one solution, we set it equal to 0. So I'm just gonna isolate P, I guess. (24/9) times Q. This is kind of bad. My 9 looks just like my Q. um, 8/3 times Q. And so now we can just say, if we just make P equal 1, then Q has to equal 3/8. That would work. Um, Something like that could work, I think. Just looking at that piece as a function. Humberto, I don't use AI to help me in math. I usually, if I ask a question, I'll usually just try and find some like Stack Exchange thread. Because usually for any math question you have, there's some Stack Exchange thread on it or related to it. And then no solution would be less than 0. Top is problematic for some models. Oh, that's interesting. Yeah, Luke, I think what you're saying is basically the same idea. We're just kind of thinking about it differently. Or like, what you're saying also sounds correct, I think. For the last case, I could say P equals 0, Q equals 1, and we'd be good. As Lucas said it, we only need to give examples, I think. I guess I mean, we could say that the region, like we could solve each of these. That's kind of, we get a parabola of points for the one solution case, which I wonder if there's something to that. Oh, this would be kind of cool to graph. I want to go to Desmos. See, it usually is. I've never done a problem that's like this before, so I don't really know. I'm gonna pretend, I guess P is X, Q is Y. I'm stupid equals 0, I guess. Okay. And so when it's equal to 0, that's one solution. When it's greater than 0, that's two solutions. So it's that entire region. Ooh. And then the green region is no solution. Um, Humberto, I'm not a huge fan of AI for learning things that are new because AI can just be flat out wrong. If you want to like ask about something you already know and you can verify or have a guess for whether the things it's saying are right or wrong, then okay. But if you're completely unfamiliar with it, I'd really recommend that you look for non-AI resources. There's lectures on YouTube. This is if you're just doing calculus, I really like this website for like a first introduction. Um, I mean, I personally wouldn't trust it for that, or even if it's something that's completely new, I wouldn't really trust that. Oh, Clonk. Thank you so much for the raid, Clonk. I hope your stream was good. Um, Vern was here. Clonk is an awesome person. Plays Daisy, makes music. It's just a chill person. I hope your stream was good, Clonk. Thank you so much for the raid. For anyone who's new here, I'm Don. I do math help streams. That's what you're seeing right now. I also play Daisy about once a week. I was just playing yesterday. And actually, I was playing Namalsk and I killed a suit for the first time, which was fun. Um, yeah. We are just looking. We were making pretty graphs. Zach, hello, hello. We did do F double prime. Yeah, Jasu. So Lucas. Okay, actually, we can use the graph that I made to check your solutions. Okay, so you have the point 0, 0, which is right on the parabola there, so that's perfect for one solution. For two solutions, you said q could equal 0, which is the y-axis, and p can be less than 0. Okay, yeah, so you're getting all the solutions on the y-axis down. Wait, no, on the x-axis on the left here. And so that works. Anything with q equals 0 works. You only just clocked his username. Have you checked out his stream, Jasu? I can't remember if I've seen you in his chat, but Eats His Way by AK Zach also streams. I should be better about shoutouts. Two solutions, p greater than 0, q greater than 0. Not in general. So Lucas, if you're saying two solutions for p greater than 0 and q greater than 0, that's the entire upper right part here. But this region here is a problem. Only the blue region is good. Hey, Syntax. Your third thing for two solutions is good though, with p and q less than 0 because you're down there in the lower left. And that's all blue. For no solutions, p equals 0, q greater than 0, that's fine. P less than 0, q greater than 0. Not necessarily fine, because there's two colors here, well, three. Q less than 0, P is R? I don't know what that last one means. So, some things you put there are okay, but others aren't. So bring Mayday yesterday from brought a bottle per se. Per se in Finnish means but. What is per se alcohol? Ooh. That looks good. Whatever it is. Wait. It's from Portugal. Huh. Fair enough. He is all numbers except complex. Oh, I see what you mean with that. Um, Q less than 0 is a problem though for no solutions. If Q is less than 0, you always have at least one. What's happening, chat? The Chosen. Been telling all the folks here about the Per Se School, which is a posh private school in Cambridge. Explain them the unfortunate meaning of the school. To ass school. I would go to ass school. Yeah, I think like um if you want the regions, Lucas, the simplest way of doing it is just to rearrange these equalities and inequalities. Sometimes say your kid's a community college started his ass degree. The associates of science. um so if you want every solution for P and Q, I would just rearrange these. So or even we already did it here. Like you can say P squared is greater than 8 over 3Q, P squared equals that, or P squared is less than 8 over 3Q. And those are your regions there. That's the best way of expressing this. £8,600 per term. Oh my god, that gets charged on tuition? Wait, I thought VAT was just like imports and exports or something. I don't know what VAT actually is. Maybe it's just the general tax. Value added tax. Oh, okay. All right. See you, Zach. Thanks for popping in. Your net fellow. Oh no. Do you want me to re-explain any of this? Um, 11,476. You guys spend your entire 4-year degree in 5 years for less than that? I wish I got my degree for less than that. I even paid for a portion of tuition on my time, and I still came out with more than triple that in debt. I'm not sure which part you missed, Lucas, but if there's a part that you want to hear again, well, let me know. Didn't stay on campus? Okay, that helps. Think about representing the Fibonacci sequence as a matrix. Yeah, syntax. I just looked at that recently. Do you want to go through it? I have to remember how exactly it works, but 160 bucks a year in Finland. Oh, that sounds amazing, Jasu. I'm currently about to spend a lot of money on getting a master's. And I've been figuring out the best way to actually pay for that. Zoom out. Oh yeah. Made a function of p and q in some cases p less than 0 wasn't possible. Q less than 0 is possible for another function. Um, the Tribonacci sequence. Ooh, that could be a fun thing. We can try that. I'm not particularly good with it, but we could try and investigate that. Yeah, the weird thing about this is that if you plug in a negative number for p, it just gets squared to be positive again. So it's actually like p less than 0, p greater than 0 isn't all that different. I assume there will be 3. Yeah, syntax. Um, so you can plug anything you want in for p. It just will get squared. So it's going to flip to being positive anyway. So p can be less than 0, but p squared will always be positive or 0. And so I'm saying this because in some of your solutions, you sometimes had p greater than 0, q greater than 0. But that's really not saying all that much. Like you could have also, like, the p greater than 0 case is the exact same as the p less than 0 case. So it's like you're kind of, you can talk about these two things at the same time. But even then, like the way that takes the least, like you're getting kind of specific. Like this way here is the least amount of thinking, and it's the most accurate, or the most like complete. Is Tribonacci fn minus 1 plus fn minus 2 plus fn minus 3? I assume that's Tribonacci. So the entirety of all values there for p and q. No, this covers every... It'll be saying yes? Okay. Um, this covers every possible combination of P and Q here. So you're getting specific families of solutions, like when you're saying P greater than 0, Q greater than 0, you're talking about this entire region here. And so you can do that, but it's like um you have to worry about the overlap here because it's not all the same. And you're missing out on the entire like other piece of the puzzle there. Well, yeah. So P greater than 0, Q greater than 0 isn't quite right for anything because this one is a P axis, this one is a Q axis, if I remember right. Yeah, that's this exact inequality here, Lucas. If we divide out the three, we get the same thing. And so that's perfectly acceptable too. Like this and this are the same thing. Well, yeah, Jasu, but that's what the problem kind of calls for, I think. You generalize to N Bonacci, then use Infinacci to sum up all the numbers in a triangle going upward forever. Oh, that was your thing. Or no? Oh, okay. That's for the Pascal triangle. Oh, okay, okay. Infinacci, that sounds crazy. What's your other question? I want to think about syntax's question too, because I'm kind of interested to look into it. Um, when you set this up for Fibonacci, just regular Fibonacci, uh, you say that you take a vector fn minus 1, you set it equal to a matrix 1 1 fn minus 1 fn minus 2 1 0. There we go. Okay, good. It's extension of your simplex research. Okay, that's what I was thinking of it, and then I realized that maybe I was being hasty in involving it. So how does this system look now? That's not, that should be 2. So 1 1 1. What's our vector? I'm making this too close. Fn minus 1, Fn minus... Wait. Right. Dude, I'm not spacing this out evenly at all. This is really bothering me. 0, 1, 0. Okay, like that. Consider something other than F for Tribonacci? Oh, like just a different letter syntax? We can do T, I guess. Mozamo, you're asking about exact differential equations. There's a couple of questions in queue right now. Let me quickly give you a page that you can look at. I try looking at the examples here. And if you're still around by the time I get through these questions, like, ask me again. I can, go through it. And hey, code to be unique. I code a little bit. Hey, Suncup, looks like the products rule there. Just so I think the question is just saying like a tall box, basically. Like that's what they mean by a beam shape. Open on the front? Wait, so is a big side open or is a small side open? And for syntaxes, the big side is open? Okay. Let me just go through Lucas's quick. And then I assume we find the eigenvectors and eigenvalues, but I don't remember like what they mean or what we do with them. So Lucas, this is like a calculus optimization question. The volume of the box. Well, the bottom is a square, so I'm going to call that S, and I'm going to call the height of the box H. So the volume of this thing is side times height, or S squared H. The surface area, we have a square on the top and a square on the bottom, so 2S squared. And then we would have 4 rectangles, S times H, but one of them is open. So I'm going to say 3S times H instead. And we have 3 decimeter, 3 square decimeters of material. So we know this has to add up to 3. The surface area. And so these types of problems always have something like this where we want to optimize the volume. Like we want the maximum volume. And in order to figure that out, we're going to need to know about the surface area. Because we can't just go right to optimizing the volume. We don't know yet how to deal with, like S and H are both variables, and we can only deal with things that have one variable for now. and later on you'll learn how to deal with things with multiple. But we can get rid of one of these variables because the second equation gives us a way of doing that. So I'm going to take this and rearrange it. I'm going to isolate h. So I'm going to say 3sh is equal to 3 minus 2s squared and divide out 3s. H is equal to 3 minus 2s squared over s, 3s. So that means back up to volume, it's also equal to s squared times 3 minus 2s squared over 3s. And if we clean that up a bit, we can get 3s minus 2s cubed over 3. So let me rewrite that over here. 3s minus 2s cubed over 3. This is now the volume in terms of one variable. We want to optimize that. So let's take the derivative and set it equal to 0. So v prime, I'm going to split this up into two. Before I do that, let's split up into two fractions. So that's a little bit easier. 3s over s is just s minus 2/3 s cubed. Now take the derivative of that. 1 minus 2s squared, set it equal to 0. So s squared equals 1/2. So s equals plus or minus 1 over root 2. And this is, we're not going to have a negative length, so we only care about the positive square root. Importantly, this graph here is a parabola facing downward. It looks something like that. I lied, it looks something like that. And that point right there that we just found is a maximum. It goes from increasing to decreasing. Oh wait, no, I'm sorry. I'm drawing this wrong. The point we found is right here. It goes from positive to negative is the point I was trying to make, which means that this is a maximum and not a minimum. Sorry that I'm being confusing there. That point right there is s equals 1 over root 2. And so that's that dimension that optimizes the volume. We still need to find the height. And we have this handy equation right here. So take this equation, plug in our s, and that's the final thing we need. 3 minus 2 times 1 over root 2 squared is 1/2. Uh, 3 minus 1 is 2. Dividing by 1 over root 2 is like multiplying by root 2. That 3 stays on there. So I'd say the question is for the dimensions of the box. And so these are the dimensions here. 1 over root 2 for the small side, 2 root 2 over 3 for the long side. Let me know if you have any questions about that. In the meantime, I want to remember what this means about. Awesome. Fibonacci. Units, units, who cares about units? These are both decimeters. Who even uses decimeters anyway? DM. That such an annoying one though. Like I feel like I never see it. Um, where does this book over? It goes over Fibonacci somewhere. Come on, Control F isn't doing anything. If I hit enter harder, will that help? I guess not. You earned hitting students with the rules where no units are giving. Keep the hitting part in your head. Cytos. A, a certified Cytos challenge question. I ever got a syntax question that I'm working on right now. $265. Please. Oh yeah. Hi Papadoria. You're trying to make a closed form expression for the floor function? I can't imagine that's easily possible. It's you have one that's undefined at integers? That's kind of ironic. Oh my god, this is painful. Fibonacci sequence. The Wikipedia page should have the linear algebra way, right? Oh, of course you do syntax. Do you want to share it? Papadori might be interested. It's all thanks to assign pi x in the denominator. Interesting. Oh, I should explain why we care about that. Okay, fine. Let's just find I won't do it by hand because I assume that's not really the question. But we can get the eigenvalues and eigenvectors for the Tribonacci. There it is. Oh, you get complex ones. Oh, interesting. You don't know what D and C are supposed to be, though. Hmm. That's only partially helpful, I guess. Really, so we get complex eigenvalues and eigenvectors. So, like, this matrix seems pretty easily extendable. You just keep getting ones in this off diagonal in zero everywhere else. Oh, tangent does have undefined values. Okay, yeah. So that it's not necessarily better than Papadoria's. So I assume this version of the golden ratio like is slightly higher. Like this is our new like limiting value. What do complex eigenvalues mean? Well, in the linear algebra sense, that usually means you're rotating vectors. But I don't know what that means for Fibonacci. It probably means some type of, well, it can't be. I think with sequences it can sometimes mean like periodicity, like there's fluctuations. Um, but that doesn't really make sense here. Like the Tribonacci would not fluctuate, it's just increasing. But I mean, these are the eigenvalues and eigenvectors not for Tn, but for Tn minus 1 and Tn minus 2. I still. Hmm. I'm sure someone has asked this before, right? Hey, MMD. Senkalp. Uh, oh, I might be able to actually do that. It does proof by decimals. Okay. I might be able to quickly. I am really interested to see to figure out the interpretation of those complex eigenvalues and vectors. Like, in what sense would they be rotating or periodic or something? How many people would it take to lift an Abrams tank? Oh my god. Um. Okay. I'm sorry. I'm getting. How much does an Abrams tank weigh? 68 tons. How much weight can the average person lift? Let's, I guess, split the middle. What is that? 105? 110? I'm gonna call it 110. 68 tons to pounds. 110. 1,362 people. There you go, Tyler. We add... Oh, a weighted. Hmm. Oh, wait. No, never mind. I'm not quite sure what... Hmm. Oh, hey, someone's asked this before. Yeah, I'll take a look at it in a minute. Sankope. I think I can do it. I just want to talk a little bit more about Syntax's question. Oh, apparently Papadoria... Oh, yeah, in response to Syntax's floor function, Papadoria posted his in the Discord. Oops, not that. Maybe a similar-ish idea. Not sure though. Um, it's kind of like Arcane for the simplicity. Fair enough. Oh, all right. Fair enough. Syntax. Yeah, I wish I could figure this out quicker, but I don't really know how you're supposed to think about that, if at all. Um, Yeah, enjoy your music. It's like Aradia. Yeah, that's what I was thinking too. Aradia. We can try and actually do this out here now. That syntax is dipped anyway. Um, length L. Hey, Bavia. Yeah, it's been a long time. How have you been? This is our axis of rotation here. A, B. And so, the important thing to remember here is that the moment of inertia is the integral r squared dm, and that dm is equal to linear density times a small length dl, or I guess dx here, like that. So we can take this, plug it into the integral. Here r is just going to be x, and then dm is lambda 0, 1 plus lx dx, and then x ranges from 0 to l. And now that's just an integral that we can solve. Let me actually transfer this somewhere else. Interview for university tomorrow? Ooh, nice. What kind of degree are you going for? Physics? Ooh, that's awesome. I assume if you're interviewing, are you going for like a master's or a PhD? Um, master's planning to do a PhD in astrophysics. Oh, that's super exciting. Good luck with your interview. So I think this is the answer here. Sandcult. Astrophysics would be so cool to learn about. You're going for a PhD in the US. Okay, nice. I don't know if you're still here, Sandcult, but that's how I do it. Okay, Cytos, I don't know if you're still here, but let me take a look at your. How would you put? Astrochemistry. Ooh. Jasu, I feel like you just do everything. In my mind, that there is nothing that you can't do. quantum chemistry, which is physics. Huh. No worries, Saint Cult. Thank you for the question and for your patience. No, Jasu. You can do everything, including wearing many hats, both literally and figuratively. I bet you could wear at least 5 hats at the same time. Uh, is this one half? Is this asking whether one half? It's asking to compare one half p squared and p, and surely the one man jury has a better chance because if you square a number less than one, you reduce it. If you multiply by something by a half, you reduce it. All right, I don't see Sinus typing in chat, so I'll type them in the Discord. Oh, I didn't realize that you were touching a question with that, Papadoria. Um, Papadoria is asking, the goal is to make the domain all real numbers. Currently is not because of the minus sign tau x in the denominator. You don't think the solution is that simple, but it's not hard. Oh. Um, I don't know. I don't like probability. Oh, that's a funky looking function already. It's not over yet though. Okay. Where are the chances of that? 100%. So this is Papadoria's closed form for the floor function. The thing that Papadoria doesn't like is that it's undefined, ironically, at integer values of x. And Papadoria is asking if there's a way to fix that. And the issue specifically is that sine 2 pi x. Need your whiteboard to think. I don't really know what any of this is doing, to be honest. I assume this entire piece is getting the fractional part of x, and we're subtracting it off. The question, Bhavya, is that this function here is a proposed like closed form for the floor of x. The issue is that it's not defined for integer values of x, ironically. And Puppeter's asking if we can fix that somehow. The issue specifically is that minus sine of 2 pi x, that makes it undefined at integer x. Oh, okay, Slim. Um, I'm gonna say I have no clue like how any of this is doing that. I don't know how this thing works. Yeah, I don't know where to start with that thing. I'm sorry. I'm just gonna move on. It's posted in the Discord though, if someone wants to try with it, but I don't freaking know. Do I do discrete math? Um, if it's very basic, I can probably figure it out. It's not my strong suit though. Combinations versus permutations. Um, I bet someone could give a much better explanation than I could, but let me see if I can try. What permutations and combinations? I don't. Um, So, oh yeah, I mean, I can explain the basic difference between a combination and permutation. I don't know if you mean something more in depth though. Like a permutation is the number of arrangements where order does matter, and a combination is the order of, or it is a number of combinations where order does not matter, which is why this extra r factorial shows up on the bottom, because if order doesn't matter, then you uh there's less like unique results, I guess. So it should be smaller. But I don't know if that's what you mean by asking you to help understand combinations versus permutations. Is it Mert? I wouldn't know. I guess I can kind of see what the idea of that would be, but I haven't seen that explained that way before. So yeah, probably. I'm kind of like losing confidence here because I feel like you're looking for something that's maybe more in depth than I probably can talk about, or you're always asking very generally, and so my default is to just go to that basic explanation. But I think if you're taking a final on it, you probably want something more in depth, and I don't really know where to go with this. So yeah, like that's kind of the issue with how I'm trying to interpret your question. Like if you want to give an example of a specific one, we can try and reason through it, but I that's just a little bit too general for me. I feel like I played this before. I don't like competition math. I think I remember you saying asking me the exact same thing a few days ago. Everyone can try and follow on with what Mert is saying. Noob? Okay, go somewhere else. How do you reason through this for number five? Yeah, I got called a noob for not wanting to do an aim problem. If only the world was that peaceful. Usually when I say stuff like that to people in the YouTube chat, they kind of like freak out on me and start spamming stuff. So I don't know if that's the way of peace. Yeah, The thing I've been studying today in the downtime is like torque, in physics, and five is it's kind of weirding me out. I don't know where the stick is. Is the stick on Earth? Is the stick floating in space? Is it anchored to something? If it's just floating in space, I would assume C has the biggest, like, I assume in A's situation, it would just, the center mass would stay in one spot and it would rotate in place. C would not rotate at all and just translate to the right, and B would be a combination. So maybe they're looking for C. I I'm not really that confident in understanding what A wouldn't A rotate forward. I mean, maybe I I've never been in space. I don't know what, like, how to predict that. It might rotate and translate. You're right. I don't know though. With energy, what's the energy argument? I guess it was kinetic energy, right? I guess I know that. I guess it's usually. I think the book made a point that it's not always, but like, I guess that it's that. Hey, Aryan, welcome in. I guess we know it's equal to F delta X, the work. Oh, wait. Maybe whatever point we push on becomes the axis of rotation. Does that make sense? Like, wait, or no, maybe the opposite of the point would become the axis of rotation. Maybe this point would translate straight to the right, and like the point up here would like rotate but also translate like a spiral. Is that what would happen? Tomorrow's your math IGCSE paper? Oh, well, good luck. No, I don't know if what I said makes sense. I don't think it does. I don't know how to predict this. How do we figure out how it splits, I guess? Oh, technically that's ICM VCM. Uh, 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 Sure. Well, like the translating, but like if A is rotating around here, it still has a rotational velocity, the center of mass. Working on 2 hours of sleep here, no worries. I appreciate you even trying. So I guess I'm worried about rotational velocity also, because they don't seem to be talking about just only translational. This is like, I'm thinking it would make sense if you push on the top end of the stick, the axis would be like on the bottom end. Like, I feel like it should be like a complement. And if you push right here, then the axis should be like down there. And around number 5. And then if you push right on the middle, there shouldn't be any rotation. Rohan is saying A is the highest angular velocity, C will have the highest translational velocity. That feels right. But it would depend on the length of the rod to actually compare those two, I would think. The white screen is slowly waking you up. It's working. Did I play Resident Evil 4? No, I don't think so. I don't think I played Resident Evil 4. I played a little bit of the one in Africa. I think that was 5 or 6 though. I never been super into Resident Evil. Oh wait. No, I have 10 hours in Resident Evil 4. I remember I have played that. There's a short little dude who's the king of a castle. I think I stopped somewhere around getting into his castle. What's the answer? I can find what the answer is. I'm just... Well, they're just asking, like, what's the largest resulting center mass velocity? The longer the rod is, the more angular velocity the center mass has in A. Whereas in C, it's always the same velocity no matter what the length of the rod is. That's why I'm saying it depends, I think. Oh, I got like halfway through. Dang. The worst ones are 5 and 6? I wonder I was just playing the bad ones. I've never been super into Resident Evil. Force F will be used to increase the velocity of the center mass. On other cases, the part of the force F will be used to rotate and translate. That kind of makes sense, Sanko. But I'm wondering if the combination, like, B is my dark horse answer, because in B, the center mass is going to have both a translational and a rotational. Like, I feel like it's going to follow like a spiral, and that maybe makes its velocity bigger. I don't know. This one, maybe it's time to check the answer though. I haven't checked the answers for any of the ones that I've worked on, so we're gonna check the answers for 1 through 5. For number 1, I said B. And the answer is B. For number 2, I said 1 and 3, and that's the answer. For 3, I said D, and that's the answer. Hell yeah. For 7.4, I said B, and that's the answer. Hell yeah. It is C. All six have the same total energy E, because you do the same work F delta X. Equation 7.8, that's the energy. Omega is non-zero, so the energy is wasted in rotational motion. See, now, I wish they said VCM specifically, because the wording of the question, as I understood it, didn't exclude rotational velocity from being included in that. Sleep is for the weak. Yeah, Bobby, clearly the answer is you need less sleep, not more. So there's been a couple questions throughout this book. Like, I feel like every chapter there's at least one question where I have an issue with the wording. This is the second one in this chapter where I've had an issue with the wording, I think. But, oh well. It's still overall a good book. So let's think about number 6. A-level differentiation question? I probably could. Manal, do you want to give me it? You can type it there in chat, or you can put it in my Discord. Acceleration A to B defined positive rightward. It's angular acceleration A be defined positive clockwise. Clockwise is that direction around. Aren't these both negative? If we're pulling the rug this way, the ball's getting rotated around that direction, which means it's rolling to the left. So I feel like they should both be negative. But let me see if I can find... Manal's question. May, June 20... Oh wait, my place is looping. 1 second. There we go. Question 4. I hope this is the right one. I think it is. And you want to do this. Let me bring it in. Doesn't A depend upon the friction? No, it's always going to be resisting, right? Like, um, it's hard for me to describe it, but I don't know. Hey, Dumode. Nothing much. How about you? Okay, I guess for A, let's just take the derivative and see what happens. Y is equal to e to the minus 4x tan x. Yeah, I remember your username. It's good to have you. You can try me. I can't promise with mechanics, but I'll take a look at it at least. So we take the derivative of this. It's a product rule. Hey, Fembucks. E to the minus 4x tan x plus e to the minus 4x. Derivative tangent is secant squared x. Not a piece of cake for me usually, but oh, this is kind of stupid. Okay, I see where they're going with this. Okay, so we're gonna take this and factor out a secant squared. And an e to the minus 4x. I don't know why they put the e to the minus 4x on the right side, but we can do that. You thought it was an integral? Oh no. So factor secant squared x out. This term, we're also going to factor out an e to the minus 4x. But, so that term is going to become a minus 4 tan x over secant squared x plus 1 e to the minus 4x. I'm just forcing the outside parts to be right, and then we'll clean up the inside part. Math discussion or math homework help, whichever one is easier for you. Now when you think about what tangent over secant squared is, let me do it off to the side here. Tangent is sine over cosine. Secant squared is 1 over cosine squared. Hey, Krim. Yeah, Fabia is calling it. So this cosine squared will flip up to the top. And so we're going to get sine x cosine x. Because one of the cosines will cancel with that cosine. And if we know our trig identities, we know that sine of 2x is equal to 2 sine x cosine x. So if you divide the 2 over to the other side, we could say that sine x cosine x is equal to sine 2x over 2. So what it becomes over in the black part here, the minus 4 is still up front. Actually, I guess we're going to cancel it with that too. So we're going to get a minus 2 sine 2x plus 1 e to the minus 4x. And I guess I should maybe flip the order of that just to make it exactly match the format they give, but this is just the answer here for part A. This question is from Manal Zane. It's so funny when I realized I was a kid, I used to think they teach it for math, physics in other countries in high school, solving foreign journals. Fair enough, Rohan. I guess it's 4 marks, yeah. And so now they want us to find the stationary points. So we just set this thing equal to 0. We also have this interval to work in, 0 to pi over 2. So we're going to take dy by dx secant squared x 1 minus 2 sine 2x e to the minus 4x. Set it equal to 0 and solve it specifically when 0 is less than or equal to x is less than pi over 2. Yeah. And so what you do from here is you split up into 3 equations based on the multiplication. So the secant squared gets its own equation. the 1 minus 2 sine 2x gets its own equation. And the e to the minus 4x gets its own equation. So looking at the secant squared one first, I can just know from the graph of this that we never get any x's from that. But to actually show that, we can remember that secant squared is 1 over cosine squared. And good luck naming an x that gives you 0 on the left-hand side. It just can't be done. The numerator is always 1. And there's nothing you can divide by to get 0. So we don't get any x's from the first one, and that's okay. The second one, let's try to isolate x. If we subtract the 1 over and divide by a negative 2, we get sine 2x equals minus a half. Now let's take the inverse sine of each side. 2x equals arc sine minus a half. But because we're taking arc sine, we do have to... Oh, wait. Taking the arc sine of things is funky. Positive? Oh, thank you. Positive. Sine has period 2 pi, so we'd have to add plus 2k pi. We shouldn't have to worry about it because of this, but just to be safe. The issue is there's a second thing that we need to do here too. Because there's 2 solutions in the first 4 quadrants, and we need to find what the other one is going to be. So sine could be equal to 1/2 in the first quadrant, which is this thing here, or in the second quadrant. So we need to take pi minus arc sine of a half as well. And that'll be the second quadrant solution. And so honestly, we can just forget about the 2k pi's. We're not going to need them because of this domain restriction. In general, you do need them, but for this one, we don't. From the first equation, 2x would equal pi over... Okay, yeah, I see. It would equal pi over 3, right? And then this one, 2x would equal... No, I'm sorry, it's not pi over 3. No, it's pi over 6. And it's going to be pi over 12, yeah. This one down here is going to be 5 pi over 6. And then we're going to divide each side through by 2. So we're going to get pi over 12. And so the weird thing here, 5 pi over 6 is outside of the domain. It's more than pi over 2. But once we divide it in half, it gets inside of the domain. It just barely kind of like squeaks in there. So the 2 stationary points are pi over 12 and 5 pi over 12. And that's just the entire answer to the problem, I think. So let me know if you have any questions on that, Manal. Oh, yeah. Skeleton, thank you so much for the sub. Holy crap. Root 2 plus root 3 is about pi? I gotta see that. No worries, Manal. Thank you for the question. .14. Okay, yeah. I used to 2 decimals. It's good. It's funny. Okay, so Duma had posted a question, I think. Oh, majority. Ugh. I see. Uh, sorry, I'm talking about a different problem. So this is Dumoulid's first question. Okay, so the equations of motions for both of these are going to be, I'll say the y, like we're only talking about here, so I'm just going to use y. The y coordinate for the first ball, ball A, is um let me put the general equation first. Y is equal to starting y, as in like y naught, plus starting velocity times time plus 1/2 gravity squared. And we're going to say that gravity is equal to 9.8 meters per second squared. And so for A, ball A, square root of g is about pi, that's true. So the first ball, it starts 50 meters above the ground, so that's y naught. The starting velocity is 2. Upwards 2. Sorry, we need to be careful about what's up and what's down. We're going to say gravity is down, so minus 9.8, and the starting velocity is up. So this is positive 2, t, and then minus 1/2 times 9.8, t squared. And then for B, yeah, Bob, yeah. B starts on the ground, so y naught is 0. The starting velocity is 20, and then the same gravity. I mean, you could do the entire problem just like we're making parabolas that are like that. You could do the entire problem and make the flipped parabolas, and you'll get the same results. It doesn't really make as much sense though. Like I wouldn't do it like that. You could define it the other way if you want. It just wouldn't make much sense. Or like it. Yeah, I know. You probably could make it make sense, but this way it's much more natural. Obviously, that down is down. Okay, and so to find capital T, which is the time where they intersect, or not intersect, but where they have the same height, we're just going to take that instead of equal to that. That's what we're interested in. And then solve for T. That's kind of funny. The gravity terms cancel. I guess so. Don't pursue math if you just like numbers. You rarely see them. That's kind of true. Accounting is where you want to go for numbers. Hi, back again. I'm Don. Okay, so yeah, I guess the gravity terms cancel out. That feels very weird. But Yeah, those two are going to go away. I'm going to subtract 2t to the other side. So we're going to get 50 equals 18t. It's normal? Okay. Oh, yeah, it does make sense. It makes sense. I know why. They should only intersect once. And then divide the 18 over 25 over 9. So after 2 point something seconds. Oh, interesting interpretation, Krim. I was thinking about it in terms of the like I was imagining parabolas the way that I was drawing them before, where they both start at 0. And so I thought we would get 2 intersection points. But what actually happens is one of them has a like starts higher up. So we only get the one. It's correct? Okay. Do you want to see part B as well, or is that all? Part B is easy. Okay. How did I use that equation? Like this equation up here? Oh, I just have that one memorized. If you know calculus, we can build this up. If you don't know calculus, I think you just have to memorize it, unfortunately. But this is just the equation for the height of a projectile in free fall. Not much. Like, do you know how to do an integral? That's the only requirement. Okay, then yeah, let me show you how to build that equation up. Let me set up the situation first. Launch vertically upward from a starting height y0 with initial velocity v0. Find its height at any time t. Okay. So the first thing to do is to interpret some of the words here. The starting height y of 0 means that if y is a function of time, then y of 0 is equal to y naught. And then same thing with the velocity. If velocity is a function of time, then what that part is telling us is that v of 0 is v naught. And so now the thing to actually get started on this is to look at the acceleration of this thing, because the acceleration is really simple. The acceleration at any time is equal to negative gravity. It's always accelerating down. Exactly. What y0 is initial vertical position. Oh yeah, Bavia, fair. I think that's also valid. And so the thing to remember is that acceleration is also the time derivative of velocity. So if we can take this thing and integrate each side with respect to time and get the velocity. So let me do that. The integral of a of t dt is equal to velocity, which is equal to the integral of minus g dt, which is minus gt plus some constant c. Pi is about pi, the best estimate of all. And then we can apply our initial condition that v of 0 is equal to v naught, which is equal to 0, that part zeroes out, plus c. And so our v of t equation becomes minus gt plus v naught. Krim, we're using Gravity by James Hart. No. So, this is a really important thing to remember. Acceleration. Sorry. The derivative of velocity is acceleration. So if you have acceleration and want to get velocity, you need to integrate. If you have velocity and want to get acceleration, you take the derivative. Yeah, no worries. Like, derivative gives you the rate of change. The rate of change of velocity is acceleration. No, do not apologize. This is how you learn. And so by the same logic, the rate of change of position, dy dt, is velocity. And so I could even have just started this argument by saying that acceleration is the second derivative of position and do this exact same math, but never talk about a or v. Just talk about derivatives of position. I'll keep it going with the way that I've been doing it, but just know that's also a way. But yeah, and so the way to proceed from here is to do, like, use the fact that I just said velocity is the derivative of position. So if we want position, let's integrate it. So y of t is the integral of velocity, which is the integral minus gt plus v naught dt. Now we integrate. That's where our minus 1/2 gt squared comes from. That v naught is a constant, so it becomes v naught t. And then we get another constant. I'll make it a different thing, d. Now we apply our initial condition. Y of 0 equals y naught, which also equals this, plugging in 0. 0 plus 0 plus d. So just d equals y naught. So that tells us that y of t is minus 1/2 gt squared plus v naught t plus y naught. So that's where that equation comes from. All you need to know is that everything accelerates, or gravity makes everything accelerate at the same rate. It doesn't matter what the object is, the acceleration is always the same. That's the fact that you start from. And once you know the acceleration, you can use calculus to get all the other equations. This is an exact thing that when I first took a calculus class, I realized on my own, and that made me really like math. It's like, oh, this is actually helpful. Induction? Yeah, sure. Prim, the only book that I've read for E&M is this one, and I loved it. Griffiths is the other popular alternative. The difference that I've heard between them is this one, Purcell and Morin, is more intuitive, and Griffiths is more math-based. So it kind of depends on what emphasis you're looking for, but I can definitely recommend Purcell and Morin. Griffiths is also supposed to be good, though, and you probably can't go wrong with either. But I only have experience with this one. Make chance points even option, major points odd. Yeah, that's true, Skeleton. That's not perfect, is it? Like I said, either you solve it or die trying. um, the problems are great. Yeah. So like I have a playlist on YouTube of all the, because I did a reading group on that book last year. And so literally every week I would go through, how do I get the actual link for this stupid thing? Sorry for the light mode, but I'm a light mode enjoyer. um we would just go through and answer questions from this exact textbook. I should reverse the order of this playlist. So interested in hearing discussion on that actual like textbook that exists. Oh, sorry. You just don't like it? Induction? Oh, okay. Grim. Surprised you coming from a math background chose intuitive physics over solving crazy differential equations. I mean, I'm kind of interested in seeing Griffith's interpretation of it too. I went with Purcell and Warren because it explains magnetism as a consequence of special relativity. And I was kind of interested to learn about special relativity, and I found it absolutely mind-blowing. I think relativity is amazing. So it was really fun to learn about. This is an interesting identity. Oh, this is going to come from log identities. Okay. These square must first be used to check intersection points of circles and lines? Not that I can think of, Hussein, but maybe? Okay, so for induction, you start by checking the base case, which is the smallest n that makes sense. Here, I'd say the smallest n that makes sense is n equals 1. So the summation just becomes, oh, let me write this out. The summation just becomes log of 2 minus 1, which is log of 1, which is 0. And then this function over here, log of 2 times 1 factorial over 2 to the 1 times 1 factorial. That's just 2 on top, and that's 2 on the bottom. So 2 divided by 2 is 1. So we get 0. So these both equal 0. That checks out. Okay. There's some things that happened in the YouTube chat. Speed is asking about a second order differential equation. And then Steph is asking about the sandwich theorem in series with real numbers. If light has no mass, why is it affected by gravity? Because space is curved. Okay, so I'm not. I'm going to answer the question that I was just working on first. I'll put you both in queue for right after though. And if you want, you can always go back and check the YouTube recording if you can't stick around. And I can also give you links that can talk about this too, because this website really like Paul's online notes, and he has pages for each of those. And so I'm happy to talk about them too, but just to at least give you something right now. I think the sandwich theorem for series would basically be the comparison test. as I learned it. And then speed is asking about that right there. So those were three sources that might help you, but I'm happy to actually go through and talk about these once I'm through with the induction question. Yeah, I'm a Paul's online notes shill. What can I say? I love it. Okay, so for induction, step one is the base case. That's done. Hen's like, I can do that quick. 2x plus 9 equals 17. What you do is subtract 9 from each side of the equation. So you get 2x equals 8. Now you divide each side by 2 to isolate x, and you just get x equals 4. Could make you. Sometimes they want to hear it explained. No worries, Hen's like. All right, so 2 is to assume the induction hypothesis is true. And people kind of do different things with this part. I think the technically correct thing is to just, wherever you see an n, make it a k. If you keep it as n, though, it's not very wrong. I usually do that myself because I'm lazy. But I think you're supposed to make it k. Okay. Yeah, then we'll use k since that's the A-level way. And now we prove for k plus 1. Oops, thank you. I did forget that. Oops. K plus 1 factorial. There we go. That's why we plug in k plus 1. So for this proof, you have to start from one side of the equality and work your way over to the other side. And I think the left side gives us more to work with here. So let's start with that. So when we this summation is just a bunch of these logs added together. I want to split off the k plus first one. And I want to do that because it's going to give me just the summation from r equals 1 to k, and we can use our hypothesis on that. So I'm going to say that that summation is equal to r equals 1 to just k log 2r minus 1, now plus log of whatever this thing is with k plus 1. So 2k plus 1 minus 1. Log is a logarithm. They're a little bit tough to explain quickly, but it stands for logarithm, if you'd like something to Google. And so now on this piece, I'm going to use the induction hypothesis because we can say it's equal to that. Okay, and so now, God, I hope this comes out like I hope it will. Now what? Now we're going to use log properties, because when you have two logs added together with the same base, you can multiply the insides. So this is also, what's the 2k factorial, or 2 to the k factorial, times 2k plus 1 minus 1, like that. And I'm going to hope this cleans up to be that. How's this working though? Manal, there's a queue that's kind of formed now. I can put you in line. But that's what the queue is looking like right now. CVNM. I'll try to answer that quickly because that is such a short one. X squared plus 6x minus 10 equals 0. I don't think this factors. I think you need to use the quadratic formula, as it doesn't easily factor. And so it's minus b's, and b is 6, like a, b, c. So if b is 6, then minus b is minus 6, plus or minus the square root b squared, so 36, minus 4 times a is 1 times c is negative 10. All divided by 2 times a, which is 1. So we get negative 6 plus or minus square root 36. Negative 4 times negative 10 is positive 40. 2. Negative 6 plus or minus root 76 over 2. 4 goes into 76. 76 is the same thing as 4 times 19. Yeah, that makes sense. And so we can say the same thing as 2 root 19. And so we can cancel the 2 now. We get negative 3 plus or minus root 19. Yeah, that's all I was trying to remember. Like, I think multiply 4 to get to 80, but that wasn't working out for me either. So, yeah, you just kind of need to use the quadratic formula on that one. So I don't know if this is going to work out how I hope it is, but let's just try it. So I'm going to take this entire unit and distribute it to there and to there. Because we get 2k factorial times 2k plus 1, 2 to the k factorial, minus 2k factorial over 2 to the k factorial. And so this 2 times k plus 1 can come inside. Can it? No, it can't. No, this is a bad step. I'm going to instead take this and make it equal to 2k plus 1. Yeah. This still isn't right. Oh my god, that's so tricky. Okay. Yeah, Bourbaki. You see it. Okay, so this 2k plus 1 can come inside the factorial to give us 2k plus 1 factorial over 2 to the k factorial. And this is nearly the thing inside the parentheses, but it's not quite. And the thing to recognize is that 2 times k plus 1 right there is the same thing as 2k plus 2. And that exact thing, I'm going to multiply and divide by. 2k plus 2. And on the bottom, I'm going to say 2 times k plus 1 in parentheses. Because this numerator cleanly goes into the factorial. 2k plus 2 factorial. And then this 2 gets multiplied with that 2 to the k. That k plus 1 could go into that k factorial. Tricky. Yeah. Borbaskippity. Okay, so that's how you do that induction. We need to get the speeds question now. Let me take my cue and shove it somewhere else. A Rubik's Cube right now? Not very, I'm sorry. But there's too many questions to deal with. So speed wants to do a second order non-homogeneous differential equation, linear. Okay. So we do these is we assume that the homogeneous solution is why am I getting stupid? Fucking e to the RT like that. Yeah, that's all. And so you can take the derivative of that twice. And plug it into this differential equation. Conclusion sentence, I've never had to do that personally. But either way, I need to move on. So we get r squared e to the minus, or e to the rt, minus r e to the rt, minus 6 e to the rt equals 0, because we're talking about a homogeneous thing, and homogeneous are equal to 0. We can divide out the e to the rt because that's never 0. So we get r squared minus r minus 6 equals 0. And now this factors to r minus 3 times r plus 2. So r equals negative 2 and 3. So the homogeneous solution is a constant times e to the minus 2t plus another constant times e to the 3t. Hey, Krim. Oh, wait. I didn't realize that that's the same Krim on YouTube. And oh my god, okay. Oh wait, you were okay. That oh my god, I didn't even connect you to as being the same person. Today, YouTube chat is being good. Oh really, Jasu? I never had to do that. That's annoying. For the particular solution, if we use undetermined coefficients, I know, well, I mean, you have a bunch of M's in your Twitch name, but for whatever reason, I just didn't connect it. I don't want a diabolical question, Dumoulin. I'm sorry. I don't like challenge questions. I like helping people with homework questions. I don't care, Dumoulin. I don't want a diabolical question. My priority is helping people with their homework, not just doing math for fun. I think the particular solution, if we have a constant, the particular should be a linear function. Let me verify that. Oh, is it only a constant? Really? Just out of I think we can take the particular solution as just A. But I'm kind of curious to see oh, nice, Bob, yeah. If we make it linear, we should just find that the linear term is 0. And so I'm kind of curious just to see how that part works. The first derivative is A, the second derivative is 0. So what we end up with is minus A minus 6AT plus B equals 2. And so we get minus A minus 6AT minus 6B equals 2. Oh, right. And so by equating coefficients, we know that A is equal to 0. And so we're just going to get minus 6B equals 2. And so B equals minus 1/3. Okay. And so that means the particular solution is just negative 1/3. So the entire solution is homogeneous plus particular, c1 e to the minus 2t plus c2 e to the 3t minus 1/3. And now we have the initial conditions. Y of 0 is 1. And y prime 0 is 0. New music's that. Yeah. I like having the music, but YouTube like will send a hate mail after you if you play music there. I don't have that set up, Krim. This is Spotify radio using the song Divine by black, but black is spelled weird. I just set it to the radio with that song. Okay, so now we're just finding C1 and C2. That's the only task that remains. Y of 0 is equal to 1 is equal to C1 plus C2 minus a third. Y prime of t is minus 2C1 e to the minus 2t plus 3C2 e to the 3t. Y prime of 0 is minus 2C1 plus 3C2. I'm nearly done with this question. Steph CE, are you still here? Let me know in chat if you are. If you're not, I might just skip over that because I need some information. Now that I think about it. Or I need to know what exactly you want to hear about, I guess. I'm going to add the 1/3 over to the other side here. So that's 4/3 equals C1 plus C2. Jonathan, hello, welcome in. We have that equation and that equation. The two unknowns, two variables, or two unknowns, two equations. C1 plus C2. 0 is minus 2C1 plus 3C2. This one has 0, so let's just do substitution for this one. C1 is 3 over 2 C2. Yep. Plug it into the top equation. 3 over 2 C2 plus C2. 4/3 equals, what is that? 5 over 2 C2. How's it going, Jonathan? 8 over 15 equals C2. It's good to hear. Okay, and then C1 is 3 over 2 times 8 over 15, which is a number. 4 over 5? Yeah. So the final answer, go back up there, plug in C1 and C2. 4/5 e to the minus 2t plus 8 over 15 e to the 3t minus a third. And there you go. So I had to check in the used books website. They print some cheap old volumes of the Elements of Math by Bourbaki and French over there. Oh, nice. Unfolding Mysteries 5, 9, 25. What the hell is that pattern? Oh, maybe his power's a 4. That's plus 4 plus 16. So would this be plus 64? 25 plus 64. 89? What's 64 times 4? I don't know math. $256. 256 plus 89. 345. Dude, how did I solve that so quickly? Wow. Actually, I didn't think I would get that. Correct? Okay. So yeah, the key is the first one is plus 4, the next one is plus 4 squared. And so I did plus 4 cubed and then checked it with the next one, which is plus 4 to the 4th. So that seems to be the pattern. French bad as it gets, most math French stuff you've tried it is okay. Yeah, I mean, I mentioned that Portuguese must help a little bit, and being able to look at the numbers. Beginner stuff, I don't know how I'm kind of shocked. I thought I'd be wrong, but yeah. Okay, Steph CE was asking earlier about the sandwich theorem for series, and I think they're talking about what I learned as the comparison test. I'll talk about it quickly here, but I wish they were here so I could ask them uh, more about what they were confused about. The idea is that some series are difficult to kind of apply a test to directly. But what we can do is we can name a series that we do know how it behaves. And as long as we can like figure out cleanly if the one that we have is greater than or less than the series that we're concerned about, we can make a statement about convergence or divergence of the original thing. Squeeze in for sequences. They said for series though. I see. I guess you're right though, Mert. Where we don't really call it the squeeze theorem for series. We do call it the squeeze theorem for sequences. But they said for engineering, which makes me think it is for series. Um, but so I'm just gonna keep on going with the comparison test here, and I hope I'm talking about the right thing. Series as sequences. Oh, I guess that's true. Yeah. Uh, so I'm gonna keep it to series and talk about the comparison test. If you want to, if you're given a series and you suspect it's convergent, you need to name a series that's greater than it that also converges. Um, the idea is that if you graph the individual terms of the sequence, not the sums, just the actual terms of the sequence. Let's say the terms of the series are dropping off to zero, and so you think it might converge. This is for some series, like some sum of a sub n that we're trying to think about. If we can name a second series that is above this and we know converges, then that black a sub n sequence must get like sandwiched in between that series and zero. And so we can say that that thing has to converge also. And we call that one like b sub n or something. In the opposite case, if we think a series diverges, then just kind of draw up above and not really dropping off to zero as quick. What you want to do the opposite. You want to name a b sub n that is less than that, and we know diverges. Because if we know the sum of these terms blows up to infinity, then it must be the thing that's greater than that also blows up to infinity. The tricky part is actually naming a series that's helpful. You normally want to use, it normally involves cutting out some part of the series that you're given. So like, if you're given that series 1 over 3 to the n plus n, it looks kind of like a geometric series 1 over 3n, and we know those converge. So a good comparison is just 1 over 3n. Monotonic sequence theorem? I think so, yeah. Yeah, I'm just going to stop there because I'm not sure what exactly they'd want to hear about, so I'm just going to stop there. Okay, I think I'm gonna wrap up with Manal's A-level question if I can find it. My voice is fading. Question 9, part B. Hey Scrim, we are just talking about the comparison test for series, and now we're digging up an A-level question someone wanted me to look at. Number 9. It's been a minute, Scrim. I hope you've been well. Hey, AN calligrapher. So this person asking specifically about part B, so we're not going to worry about A. You have? Nice. I'm glad to hear it. No, scrimp, not crim. Although you are a subset of scrimp. So I understand the confusion. Okay, so part B specifically. So that corresponds to the point on the curve where the tangent is parallel to the y-axis. Parallel to the y-axis means that dy by dx is basically infinite. Ugh, I should tangent parallel to the y-axis. Because the y-axis, points straight up. So if you have a function that looks like it does one of those, then right there at that point, the tangent goes vertical. And that's parallel to the y-axis. So what we're gonna do... Ugh. We need to find... I guess we set the denominator equal to 0. But... like, what the hell is this function? It's a relation. Not even a function, I think. But, exact coordinates... Okay, I guess we're gonna take the denominator and set it equal to 0. So anywhere where 2y equals e to the x, I guess is where we're in business. Oh, really? 10 bucks? That's awesome. I've not even cracked it open. I'm probably going to try and read chapter 5 of the relativity first. Sounds good, Pavia. Good luck with your interview. Sleep well. So, Manal, if we want, do you have idx to approach infinity? That happens when the denominator is very small. Hey, color cone. Um, and so if we just set it to be 0, that should be exactly where it hits infinity. Yeah, and so I think as Bourbaki says, we're going to take this relationship here and plug it in up there. Unfolding, that's a more difficult series. I'll have to think about that a little bit more in a second. Chapter 5 of Hartle 2. Starting confusing? Okay. Yeah, Manal, if you want something to approach infinity, you can take the denominator and set it equal to 0. Or like that's where that's where that happens. Just wanted to keep reading it. Oh, nice. So I guess y equals 1/2 e to the x, and we're gonna, well, no. Anywhere we see an e to the x up here, we're gonna plug in 2y. Let's do that direction for the substitution. So this is the same thing. E to the 2x is the same thing as e to the x squared. So I'm going to say that's 2y squared minus y squared times 2y equals 2. Beta and gamma functions? I know the gamma function, kind of. The beta function I don't think I've heard of. So now we solve this equation for y. 4y cubed minus 2y cubed equals 2. 2y cubed equals 2. Y cubed equals 1. We're only dealing with real numbers, so y equals 1. And now we go back to the original equation, plug in y equals 1, and solve for x. Or the original equation also there. So if y equals 1, then we get e to the 2x minus e to the x equals 2. This is, I'm going to subtract the 2 over. This looks weird, but it looks a hell of a lot like a quadratic equation, like x squared minus 2x. Oh, sorry. X squared minus x minus 2 equals 0. Because remember, e to the 2x is just e to the x squared. So we can solve this equation the exact same way as we would solve that equation, except instead of x, we have e to the x. So in this equation, we'd say it's x minus 2 times x plus 1, which means in this equation up here, we'd say it's e to the x minus 2 times e to the x plus 1 equals 0. And I'm deleting that. And now we split off into two separate equations. E to the x minus 2 equals 0. E to the x plus 1 equals 0. So first I'm going to get e to the x equals 2, which means ln 2 equals x. From this second equation, we get e to the x is minus 1, which there is no x for that to be true. So no solutions from there. So the answer to the question is that the x and y coordinates where the tangent is vertical or parallel to the y-axis is ln 2, 1. No worries. Unfolding series asked about Unfolding the mysteries is asking about this sequence of numbers, which the double nines, I have no, well, what? This could be something to the power of 0. And this is something to the power of 1. It's not 3, though. This one's harder. I don't see this one. I do want to wrap the stream up soon. Like I'm losing my voice here. Hey, famished. Um, you can say meth. I don't care. That's Crim's question down there. Oh yes, I like that idea because I don't really see it. There isn't really a good match. Meth would have been better. I think so. I agree. That one doesn't seem like a sequence as you've written it, unfolding the mysteries. What's up with Crim's question? Um, is that James Gandolfini as your Discord profile? I am gonna delete, or like you posted it twice. I'm probably gonna delete one of the times you posted it just to keep the conversation in one place. Hey Nikhil. Unfolding the mysteries. I was just talking about. I don't think there is a number that fits. I can't find a number that fits. I don't think that there is one. 67? Not as far as I can tell. Unless it's that, oh, maybe they're doing that stupid two sequences mashed together thing. And you have to look at every other term. Even then, I don't really see it. Yeah, I'm sorry. I don't know Unfolding the Mysteries. Sureb, I'm best with things that are like first year undergrad and below. Talking about 9? Oh, the one above? Yeah, there's supposed to be a vertical asymptote. Or wait, no. There's a vertical asymptote? There shouldn't be, I don't think. I don't know. I'm getting tired and I really want to end the stream, to be honest. I'm just trying to see if I can quickly have anything smart to say about Crim's question. I have no fucking clue, Crim. That looks really complicated. Um, the question is up in the Discord though, if anyone is interested in it. But yeah, like I said, I'm losing my voice here. I'm calling it. Students here on YouTube, thanks for being here. Back on Saturday with the reading group and then math. So thank you, YouTube folk.